So this is something new. This is something we haven't seen yet. This is constructing and interpreting what's called a residual plot, which is basically a new graph, and instead of graphing my line of best fit, what I'm actually graphing is just the residuals, or those leftover amounts. So what's the purpose of a residual plot? Well, it's either going to tell you, yes, when I drew that linear line, the data actually was linear and it was fair to draw a line, or if my residual plot is a certain way, then that'll say, well, no, your actual original graph wasn't a line, so we can't do a line of best fit because that's not a line that fits the best. It's actually a curve or something else. So all throughout this topic, we've been assuming so far that we can make a line of best fit, a least squares regression line, and that's an appropriate way to predict things. But actually, it might not always be the case. So once you've made your residual plot, and we'll look at some in a minute, if there is a pattern, so some sort of discernible pattern in that residual plot, like a curve or a line of some sort, or some sort of weird spacing, then we can say that our original scatter plot, our graph, is not a linear graph, and that's bad news. That's what we don't want, because then we can't do all of our analysis that we've learned how to do. But if we make our residual plot and there's no pattern, all the leftover, the residuals, the extra bits, are just random. That's what we're expecting and what we're hoping. Then our original scatter plot, that's actually a linear scatter plot, and we're allowed to fit the linear regression line to it, the least squares regression line. We're allowed to predict values like we learned how to do just a minute ago. We're allowed to do all those great analyses that we want to be doing. So good news if it is linear, bad news if it's not linear. But we do need to check. It's not fair to just say it looks probably about linear, so that's what we'll just go with. So here's how to do it on your calculator. As normal, construct a scatter plot. As normal, fit a least squares regression line, and then we're going to form also in our calculator a residual plot. So menu, analyze, residuals, show residual plot. That's when we're on our graph page, we will put that in. And then we can kind of just visually look and decide whether there is a pattern, and whether or not it is linear. So just again, if there is a pattern, it's not linear. If there's no pattern, it's linear. So the report will read like this. The assumption that there is a linear relationship between my two variables is confirmed or denied from the residual plot. We can, and this is just an extra bit to kind of super clarify that that's true, we can observe either no clear pattern or a clear pattern. This bit here is probably not essential. We can observe pattern, but I think just to be super safe and make sure you get the marks, that's a good idea to do that. Let's look at our particular example. So here's my original scatter plot again, and you can see I haven't put the line on it. I'd like to know, once I've fit my line, and the line looked like this when we had it on there, I'd like to know if that line does actually represent a linear relationship or not. So let's check. We put in our calculator to find the residual plot, and here's all my different data values. So you can actually see this is the residual for this piece of data, and so it actually makes sense that this is below, about that much below the line. And here where, in fact my line probably should have been a little bit lower. Here, for instance, we're quite above it, and down here we're quite above it. So they would all match up if I did my least squares regression line correctly. And here we're a little bit above it, and here we're a bit above it. Here we're underneath it, and here we're underneath it. So instead of graphing the original graph, we're actually just doing a graph of the distances. So this is a negative distance. You can see this is in a negative. This is positive. This is in a positive. Positive, positive, negative, negative. This line is like how far away from the line was each of these data values. How much residuals do we have? So it's a plot or a graph of the residuals of the leftovers. So I can't see any sort of curved pattern in this data. It looks all just completely random to me, so I'm going to say there's no clear pattern, and therefore our assumption that we assumed that it was linear, so I'm going to say yes, our original scatter plot, this one up here, was good enough to draw a linear relationship onto that, or a line. So here's my report. The assumption that there is a linear relationship between life expectancy and birth rate is confirmed by the residual plot because we can observe no clear pattern. I couldn't see a pattern, therefore I said the original must have been linear. Here's a different example. Here's the data, and if you just don't look at the red line, don't look at the blue line, it looks pretty much like actually the data is in a straight line. So they put a blue line on it, they put a least squares regression line. That's this line just here, that's my LSR line. And I thought everything was looking pretty peachy. I thought, yep, I've done a good analysis. But actually you can see from their dotted red line that the data is actually slightly curved. It actually models a curved relationship, this scatter plot, rather than a straight line. And just to super check, because we probably wouldn't notice it just from looking at this, we did a residual plot, and we could see that the data values in my residual plot actually formed like this shape here, this kind of U shape, which was bad news. So that residual plot did form a pattern of what's actually a parabola, but basically a curve and not random configuration. It did form a pattern, and therefore, bad news, there's a curve, therefore our original was not linear. And then when we go back to our original, we can say, oh yeah, it does actually, it looks like it was a curve rather than fitting a straight line. You can see there's data's all underneath here, data's over here and over here. So we need to do the residual plot to check if there's no pattern, whether yes it is linear or if there is a pattern that's not linear. So in this case my report is the assumption that there is a linear relationship between the length and the yield, that was this graph, the length of a crop and how much it's yielding, is denied